Hi everyone. I thought we'd take a few minutes and go over our measures of variation notes. So if you were absent, the notes are on our Moodle page and you can just print those off or you can fill them in on your computer. But looking at this first problem, it says suppose Mario received the following scores in math class, 92, 85, 65, 89, and so on. What's the standard deviation for his test scores? Okay, the other thing we can find is the range. And the range is just the high minus the low. So his highest test score was 96. Minus his lowest test score of 65. Isn't that fun color? For a range of 31. Okay, so if we were going to find the standard deviation, step one, we need to find the mean. So if you've got your calculator handy, pull that up, and we will enter each one of these test scores into list one. And then find the mean. Stat, calculate, one variable stats, list one. Don't have anything for your frequency list here. Calculate. So we have a mean of 83. Okay, so our mean is 83. Okay, list all of your test scores in this table. And then we're going to subtract the mean from each one of these. So we'll take each one and subtract 83 from it. 85 minus 83 is 2. 65 minus 83 is negative 18. 89 minus 83 is 6. 96 minus 83 is 13. And 71 minus 83 is negative 12. Now we can't average those because if you add them all up, they add up to 0 because we've got some positives and some negatives. So what we're going to try to do to make everything positive is we will square our deviation and then we're going to turn right around and square root it. So square each one of those numbers. 2 times 2, negative 18 squared. And so now each one of these are positive. Okay. Okay, here's the formula for standard deviation. We're going to take the square root of the sum of all of those numbers and we're going to divide it by n minus 1. So if we add all of these together, it adds up to 758. So we're going to take the square root of 758 and divide that by n minus 1. N is how many things we have. So we have 1, 2, 3, 4, 5, 6 scores. So since this is a sample standard deviation, we're going to divide by 5. And that gives us a sample standard deviation of 12.3. If we divided by 6, it would have been a population standard deviation. Going back and look at our calculator, hey, the sample standard deviation is 12.3. Okay, so after today, I don't ever want you to do one by hand, but I wanted you to know where this number came from. It's on average how far away something is from the mean. Okay. Then we have a formula for coefficient of variation where you take your standard deviation and you divide it by the mean and then you change it into a percent. Okay. So if you were to put Brinks in list 1 and maybe not Brinks in list 2, you can take a minute, you can pause the video here if you like, but you can find your mean of Brinks is 1.52 and a sample standard deviation of 0.21, and not Brinks, you'll get a mean of 1.75 and a standard deviation of 0.22. Okay, and what we're going to try to do is the coefficient of variation. Okay, so coefficient of variation for Brinks would be your standard deviation, that's a 2, over 1.52, and then change your answer to a percent, so you should get 13.8%. And then the not Brinks, 0.22 over 1.75, change that to a percent, and we'll get 12.6%. So in explaining that, I would say the Brinks employees who were collecting parking meters had more variation in their collections than not Brinks. Brinks had more variation than not Brinks. There are a couple other examples on here that you are welcome to try that are just for practice. Okay. Okay. Just a couple other things that we went over today in class. We talked about how to find a box plot and also how to tell how far away something is from the mean. So let's just look at the systolic blood pressure, the top number. Put that in list 1. $118. Some of the papers printed 136 as like a parenthesis, but it's 136. 120. Okay, so enter. Stat, calculate one variable stats with list 1. Okay, so here we have a mean, and if you go down to the bottom, you get what we call the 5-number summary. The minimum, the maximum, Q1, which is the 25th percentile, median, which is 50th percentile, and Q3, 3/4, is your 75th percentile. We can use these numbers to draw a box plot. And you could draw it by hand if you want to. Years ago, you probably learned how to do this and called it a box and whisker plot. But I'm going to show you how to do it on the calculator if you want to. Okay, stat plot is right here up above y equals. So go into second y equals, which is stat plot. All of these are probably turned off. Select the first one, highlight on, turn it on, and then come down here and pick out the one that looks like a box plot. This one. That one looks like a box plot. Now this one with the dots is more like the Michael Jordan data, when you have somebody that makes like way more money than everybody else and you've got an outlier in one direction or the other. But just for regular data, we'll do just a plain box plot list 1, frequency. Now, at this point, if you hit graph, you won't see it because our graph goes from negative 10 to 10, negative 10 to 10, and these numbers are all over 100. So they're going to be off our chart. So you can pick your own window if you want to and say, hey, this goes from like 100 to 1 whatever. But the slicker way to do this is to go to Zoom and go down until you find Zoom Stat. Zoom Stat picks a window for statistical plots. Zoom Stat, enter, and then, oh, looks like I've got some weird stuff in here. Let me erase trig from this morning. My apologies. Okay, so here's our box plot. And you may be thinking, I can't tell what those numbers are. What is the minimum? What is the max? Trace. And it will tell you what your numbers are. Minimum goes on the bottom, 96. Q1 is the bottom of your box, 118. This is your median, 124. Q3 is the top of your box, and then we have a max of 158. So that's how we make a box plot. Okay. Only other thing that we covered in class today was determining how many deviations above or below the mean a score might be. Okay. So going back and looking at Mario's test scores. Okay. We know the mean of his test score. Okay, what if someone made 100 on the test, or maybe they made 50 on the test? Would that be unusually high or unusually low? Okay, I should have left that data in my calculator, and I did not. So I'm going to throw it back in there really fast, and you can do the same thing, but write down your mean and your standard deviation. Oh, we already know the mean and standard deviation. Okay. We know the mean and standard deviation. Our standard deviation was 12.3. Okay. So my question would be, is a score of 100 unusual? Unusual is anything that's 2 standard deviations above or 2 standard deviations below. And you can probably look at it and go, 83 plus 12.3 plus 12.3 is bigger than 100. It's definitely not unusual, but you can use this formula. You can take whatever the score that you're checking minus the average score and divide it by your standard deviation. Okay, 100. 100 minus the average divided by the standard deviation, and that will tell you how many standard deviations above the mean 100 is. 100 minus 83 is 17. Divide 17 by 12.3, and we get 1.38. 1.38 is not unusual. Okay, what about a score of 50? Okay, your score minus the average over the standard deviation, and we're going to see if that's maybe more than 2 below. Okay, your score minus the average, enter, is negative 33, divided by 12.3 is negative 2.68. $50 would be unusually low. 100 is not unusual. Unusual is more than 2 standard deviations from the mean. Okay, so that is what we worked on in class today, and I hope everybody is doing well.